required with ING Netherlands, and there might be a scenario where you might be, required to process many number of messages over EMS after consuming over EMS, and that too parallelly, simultaneously, concurrently. So since EMS provides these all features while consuming over EMS queue, so we have created a POC to demonstrate that, and of course we have different types of consumers like synchronous and asynchronous, which tap into EMS queue process it in their own process space. So the whole gist was about creating some reusable artifacts in form of DLL or in form of templates, which can be provided to the developers as and when they are required to tap into EMS and get the messages from EMS over queues basically. So all those fundamentals of EMS have been discussed in about 2-3 minutes before, and we have focused here on basically providing only point-to-point integration. And when I say point-to-point, I don't mean that there's two systems integrated point-to-point. It's not from the enterprise architecture point of view; it's from messaging point of view, where EMS queues come into play, and the two systems or the source and destination are the sole senders and the receivers of the messages, and there is no third system basically, or second receiver. If there has to be one, then there are other ways of in EMS to connect them without doing any multicasting and broadcasting. Okay, so a DLL has been created, which goes like this. So these are the library contents of the DLL, and you can see that there are two asynchronous consumers using message listener and other one using delegate, and then of course there is the EMS connection and the message producers over written methods. There are quite a few of them, and they are basically implemented there in the library, and there will be a lot more probably as and when we further develop this library. And then there is one very important synchronous message consumer, which has its own method which developer would need to override. So the key characteristic of these three consumers would be that they will be providing concurrent processing, even the synchronous ones. The only difference between the synchronous consumer and the two asynchronous ones are that in the synchronous one I have to do some explicit multi-threaded programming because I could not access the sessions which I could in the asynchronous ones. So that's the major difference here. So we can use the results of the POC to finally decide which one is the best one for getting the set of parameters. So here it is now. So first of all, I will try to I will demonstrate the use of a .NET application acting as an asynchronous consumer. Okay, and as you can see here, so when I say consumer, whether synchronous or asynchronous, it's a message consumer. And message consumer means service provider. I see that you have been using service provider in the typical ESB parlance in FS. So which makes a lot of sense in the sense that of course it is not a service consumer, it is a service provider. So as and when I say consumer or a message consumer, that means service provider. And if I say message producer, it means service consumer basically. So now the typically what I've done is I have used the configuration which would be looked up into by DLL as well as the consumer also. So which means that the DLL would basically be responsible for creating the connection object, and there are four parameters for creating an object connection object, which basically the server URL and the username password and the client ID. The other two, there will be other two parameters also in the configuration, which would be meant for the consumer. Now a consumer means what? Consumer means a consumer of consuming the messages of EMS2. So the first parameter of course will be the EMS2, and other one will be the number of sessions that requires to be created when that particular consumer object is created. When I say consumer object, there will be multiple consumer objects created, but that will see a little later. So the constructor of a consumer would basically, take the, if you see here, async message consumer is the notational constructor takes string, which is the queue name, and the integer as number of sessions. And it is applicable for every, every consumer, whether it's asynchronous or synchronous. Okay. So now let's go to the typical setup where a typical designer will act as the producer of messages, and .NET applications will act as the consumer of messages. So here is the overview of .NET service provider or message consumer. So this is your typical designer which sends the messages to the EMS server, and this consumer, which might come up a little later also, starts into the EMS server to get the messages. And this consumer also refers the library, this library, and also the configuration. So let's see what is here in the configuration. So these four parameters are meant for the library. This library, which means server URL, username, password, and the client ID. It can be optional also, in some scenarios you can have null client ID also, but just for ease of administration of EMS server queues and connections, we tend to use client ID also. And then these two parameters are used by this particular consumer which is written in .NET, and of course then this project just for EMS framework has got asynchronous consumers, synchronous consumers, and producers. Like you saw in DLL also, we had all these three categories of EMS clients. So here also we have the same, and it has its own configuration, which is the password, URL, number of sessions. Well, number of sessions here would not be applicable because it's only the producer. So when it acts as a consumer, the business works code will act as a consumer, then the number of sessions will make some sense to them. So, that's it. Let me try to show you. This is our typical designer in which we will focus in this one as the producer of messages. Okay, and this is your synchronous consumer, and which can create all three types of consumers in this class, consumer creator. Okay, so this is the entry point here, and here you can see that based on the command, whatever you enter on command line, you can create asynchronous consumer with delegation, you can create asynchronous consumer with listener mechanism. Both of them can also be created, but at least they should have number of sessions greater than equal to 2 because there are two consumers of different types. And we can also create synchronous consumer using the Steve method, which you guys, Swaraj and someone have been using previously, but those were not multi-threaded. So let me try to run that. Let me see where it's built. So I'm using the Stitch one because I can recall the commands very fast, and I can use various other libraries like C, and the output on standard output also, and as well as to the file. And I have written some functions like shift cd which convert the Windows naming convention into the Unix one and then change to that directory. So if I see here, so let me try to build it. It's already up to date, so this is the one. Yeah.
Another one is the video is gone.
Video is gone.
Wait a minute. So wait. You see the next problem. Yeah, go back.
You're back. Okay.
Kind of other way. You don't touch it completely and
So what I did here was, if you have missed it, what I did here was, I just took the input from here, took the build directory and copy and then change it to that directory. So I can see that there is one. Let me do some. Yeah, still up to date. Even yeah. So if you see, it will come at the top because I am using the T option here since time stop by time. So now that's come at the top and it's now 1219 at here, and so it's the latest, and this is the build which we are talking about. So I will just try to run this. So it's a better practice to always run the consumers first because they have to consume the messages. Producers, when you ensure that consumers are running, then you start the producers. Although now AMS is sitting in between, so nothing would happen to messages, but still it's good practice. In the days of Cisco and Randago, we used to start consumers first and then the producers, because if of course there are persistent facility available in Randago also, but in reliable messaging there was no persistent messaging available in that particular reliable messaging facility. So we used to run the consumers first. So it's always a good practice to run the consumers first and then producers later. Sorry. So let's try to run the asynchronous. Whatever I do, so it will start it and it will call this constructor, QName and all, with QName and number of session, and then it will print the consumers that have been created. So before I do create a consumer, since the consumer also is a EMS client, I've forgotten to run the EMS server. So this is our EMS server, and it's written on it's listening on 722 port. So probably somewhere here also, here you will see that it's listening on 722 port. Okay. So this is the one, and then there is an administration tool which will help us, looking into what's going on in terms of how many consumers are there, how many sessions are there, the session IDs, the connection IDs, the queues and all. So there will be only one connection of the one, which is of that of this particular client itself, the administration tool itself. So this administration tool also, consumes messages over the queue, which may be a temporary queue. So if you see that this L means language, this is the C language, and this is the version of the client, this is the connection ID, and P here means the type of connection. This is admin, A here means admin. S means started or not, plus below S means it is started, the host on which the connection is made from. The IP address is here means all available IPs are used, and the user is admin here. And there is one session and one producer and one consumer created at the moment. So yeah, so that's the full display, parameter list or the features of the connection. So there is only one connection at the moment. So once I start this, let's say we start the asynchronous consumer first, using a listener mechanism. So if you see, I have called one command which I have run before, which is C command, which basically is Linux send the output to two different locations. One is the send output and the log file. And log file will be created using the date type stuff and all. So let me start it. So here you go. So it started. It says there was one message remaining somewhere, so that's consumed them. So anyway, so now that this particular same consumer is executed, this is the output of this one. So now what here has been done is that in order to track the threads, I have, so this is the main entry point, right? So here I have, named the main thread, which is basically your machine name, the process name, and the process ID. So it will be like the machine name and the process name is consumer.exe or without exe, and then the process ID, whatever that is. So process ID will be like 5204. No, not the 5204, but 5612 will be the process ID for this one. So yeah, so this is your, so the main thread will be your machine name, the exe name, and the process ID. So this method in consumers has executed in the main thread. Okay. So we have also taken into account this message which was consumed, and probably when we see into the administration tool, that will be more than one message than we have sent explicitly in the designer. So now also I have to show you the configuration here. So this one has been used, this queue has been used to tap into, okay, and this is the number of sessions. So these are configurable items as I told you before, and these are used by the consumer to create the consumers and the sessions and the threads in the .NET process space. So there are 5 numbers. So there should be 5. 1, 2, 3, 4. I think there are 5. Yeah. 1, 2, 3, 4, 5. Let me see here how many are there. So one of them here will be, consumer will be that of the administration tool itself as well. So we have to start this one. 1, 2, 3, 4, 5. And the IDs are consumer IDs are from 2 to 6. The session IDs are from 3 to 7. Okay. So now, and the connection is the same, which is 3. So if you see the connection, a new connection has been created of ID 3. Yes? And you see a hash here, which means the language is C#. And of course you can see the client ID, which is the ing lamp, which can also be seen here, which is picked from the configuration. So client ID for connection for the TMS tool is null, so it can use the null connection ID also if you are not so keen about knowing where it's connecting and what type of client it is. So there are now 6 yeah. So there are now about 1, 2, 3, 4, 5 sessions here. Okay, and they are of acknowledgement type client. So A means acknowledgement, and the client, and the C means here as the client acknowledgement. And N at the top means no acknowledgement, which is for the administration tool. And these are the uptime And as I told you before, there's one message that has already been consumed that was lying before. Probably I was looking at it yesterday, so I just sent one message on this and which I didn't consume. So that was yesterday's message, and that was sorry, my mouth is very slippery at the moment, and so this one has been already been consumed, and this was a soap message just sent, and it used some exceptions for some reason. So anyway, so now that thread has been, a main thread has been created, and then it picks up the number of sessions and the queue name, and then it picks up what has been asked to create the type, and then it consumes. And it will clear the connection ID is 3 all around. You see 3, 3, 3, 3. And same you will see here too. There So these 3 connection ID are. So I can try to show connections only on, now it's really slippery. Sorry, consumers, not connections. So they are now all using the same connection ID, and of course they will have their own individual consumer IDs, and each consumer ID is provided with a separate session ID or session. So now, as I told you, one message has already been consumed, which was of yesterday. So what I do is I start this. Now this mouse pointer is down now. A little bit difficult. Okay, let me use the pad. So if I bring it up here, it disappears. I don't know why. So these are the two senders, and this special one which uses a SOAP message to send and receive a response on, but I would not be basically looking into it at the moment, because the .NET consumer should also be SOAP based. So there would be some exception, and that previous message which you saw, which I just pulled up, that was a SOAP message, and it previous some exception. So here, so it was sent, this one is only a parent for that one, and this one is a request reply one, okay? And it will send the messages in a loop, and the loop counter will go up to counter messages. So at the moment, the counter is how much? 5. Let me just put it to 1 here for sake of simplicity first. Okay? And let me start it. Both of them basically. Not this one. Sorry, I think I see it. So these are started, and you will see that they have also created their own connections. So now here you will see that language, and the language you will see C, hash and J means Java, and the client ID is Cisco Designer. Yep. So if you see the connection details, it is asking for the same stuff, username, password, client ID, and of course the Gmail lookup, which I'm using here. So here, this is the configuration of Designer. DNS username, admin, and I'm using this one as the queue name, which is same as this one, consumer code delegator. Okay, and but here in connection, it's only connections that will only ask for the connection parameters. Consumer will ask for the, or the producer will ask for the queue parameters, queue names. So you see here that another connection has been created of type Java, because not type Java, but the client, EMS client is written in Java, and the client ID is Cisco Designer. And if you see the client ID also, it will be somewhere here. Yeah, this one, client ID is Cisco Designer. So, so now what I can do is I can start to send message from here. Okay, and see what happens here. So up till now, only one message that was previous message of yesterday that wasn't consumed. So I will send one message. Those. So now it didn't wait for the reply because it's not supposed to. It's only fire and forget. And if you see the mapping, what was sent? It's simple, business work parameters like host name, the project name, which is this one, BW test for EMS framework, and job ID, which is basically a core companion of thread, I would say. Thread info, the thread name, and the process name, which is this one, process producers and message. Okay, and if you see in the input, you will see that was sent. FF means fire and forget from machine. This one, BW project ID is this. Job ID is 19600, which is this one, 19600, and the thread name, internal thread name is job code 4, and process name is same as this one, producer. So now if you see, so this has been received here, but not this thread. This thread is the main thread, as I told earlier. Okay, this thread has received the message. EMS session dispatcher 3, which means that session ID 3 was responsible for this session ID. This one was responsible for receiving this message. So first message has been received by this session ID only. Okay, this session ID. And then no reply stuff over message reply to is null. So if it's only after a FF message, the reply to would always be null, and it is basically it has been received in the .NET. Okay, and if you see the calling sequence, first one is the process message, and then is the on message, and then followed by the other messages which are called internally, other methods which are called internally by the runtime of .NET. So let me show you this one. So this message was called implicitly by the virtue of developer, overriding this in the derived class, which is this, and it inherits from this class, and it simply process on this message to process message method, and which is part of basically the library. So let me show you what it does. So it's simply, says what is said in the output, the current thread name, okay, and then it prints the message. And then it checks whether the reply SQL is null or not. If it's not, that means the sender of the message is a requester and it's waiting for the reply. Then what it does, it sends its own stuff, .NET, runtime specification like machine name, replying process ID, thread name, client ID, and new process. So when you have to send a reply back, when the responder or the consumer has to send a reply back, it has to create another session which is used for creating the producer. So this one has been created. This producer session has been created, and then a text message is created, and the reply is text to the same with this one, and then using this send reply message, which is part of library again, the reply sent back. But now, since there is no reply to null, it comes here and says that there's no reply sought, and the say the current thread name is this, and also the method calling signal, and that's what it does here. So it basically, process message is being first successful, and then it is called by the on message, okay, and then all those runtime methods that are called internally by the EMS libraries, EMS DLLs and all, and that is all part of a higher level EMS APIs that we have been talking about. So our duty starts from here and finishes here. So on message is called implicitly, okay, and then in on message we call the process message. So in on message we can put the call to your AMP reports also, okay, and then depending upon what is if the reply is required or not, that AMP report can return, AMP function can return whatever reply it has, and that reply can be sent back to the requester. So but now this is only an effort, so we do not bother much about it. Now let me try to send the RR message. It goes. This is the input that was sent. Just as there is only an RR, everything is just the same. And output is this. That's what it receives from the .NET consumer, replying with .NET specific info. The same machine, because both consumer and producer are running on the same machine. This is the replying process name. This is the replying process ID 5612. This is the thread name. That means session number 4 has been accorded the responsibility of consuming the message and replying back, and the client ID and the new session ID, and then the message calling sequence, which means it's just the same process message and on message and all. It will be the same because it happens in the same function call. Okay. So this is. And if you see here, so now one has been added to this, and if you see, this is the session ID 4, and you will also see in the log session ID 7 is special 4, and this is the text message that has been received from BusinessWorks, okay, BW, and then this reply has been sent, which you saw in the BusinessWorks also. The same reply which you saw here. Okay. So, so these were a very simple demonstration of of consumers acting on .NET side and optionally replying based on whether the reply is available in the request message or not. And here I forgot to tell you, in case of FS, it simply sends a message to EMS queue and forgets about it. But it still gets something in return, which is this which is this. What is this? This is message ID. Now, this message ID can be used to log for tracking purpose, or you using in some APIs, in .NET APIs, this message is not returned, and that's cause for worry. For that, you probably will have to use the correlation ID. You have to create your own correlation ID here, and then because you are creating it on your own, so you will have to you can use this correlation ID for message tracking purposes. But in businessware, it is easily available. So there's not much to worry about when you are sending messages, or when you are using. So this is a message ID, and if I see in the logs, I can show you that it will be the same. So this is the one which you got in FF, because reply key is null here, and this is the message. So if you see, it's just one thing. So the consumer got what it was sent by the producer, which is evidenced by the same message ID on both the sides. Okay. So this was one message sent, as I said, one message sent as RR. Let me try to increase the discount to 5, and we will send 5 messages and see what happens. Let me reset the counter. Let me restart it, and our counters will be reset. So all are 0, because and you'll see that how they are uniformly distributed, because there are now more than one message sent at a time. Let me put it to 5. Right? So the same connection has been made on a Java client, and they are at the moment no message sent by the receivers of the consumer. So don't confuse it with sent. They are consumers, they are consuming the messages. It's just that it's a terminology in the EMS administration. When we say send, that means the receiver of the consumer or the listener is responsible for receiving and sending to the. So these are two different parts, receiver and the listener, of the same consumer. So don't get confused with this term sent. So they all set to reset to 0, and let's see what happens when I send 5 messages, 5 FF messages. There you go. So they are all gone. In a loop, I can see only the message I have the last one for the auto statement, because the other 4 iterations are hidden behind it. Or what I could have done is I could have accumulated output and named some like this. But anyway, now I'll have to restart it. I don't want to restart it again. So let me see now okay. Now the 5 messages have been received. And remember that I restarted it to clear the counters. So, and you can see the process ID was also changed. 5800. So first was 30, 31, 32, 28, 25, 29. So all are different threads which have received this 5 message. And let me see in here also. So you see that all 5 messages have been equally distributed in 5 different sessions. All threads here. I mean, you can now use sessions and threads a little bit interchangeably. Okay. So, and all of them are acknowledged. So let me tell you how, of course, they are acknowledged also. So this is a process message. It comes here, it came here, that reply to is null, and then acknowledge the message. So this is okay, and this is the else of this. When there is both the cases, message has to be acknowledged because it's a client acknowledgement. If you don't acknowledge it, it will not be deleted from the EMS server. Okay. So 5 threads have simultaneously consumed 5 messages and processed them and done whatever that is coded to be done about them. So I have not done any thread programming here. Of course not here. No thread programming here. If you see, no thread programming. I just, in the main thread, I have just renamed the thread of, just for identification purpose, the main thread. Apart from this, I have not done any thread programming. Okay? So it creates the consumer and then waits, and as soon as it gets the message, implicitly the on message function is called. Implicitly, I never called it myself. The runtime calls it, and whatever call is there, it is executed. Okay? So, and call is this one, process ENF message, it goes here and does what is supposed to be done here. Okay? So it checks basically, if it is a RR or FF message, and accordingly replies back. Or does not reply. Okay? And then acknowledges it. So all have been acknowledged. Okay? So this is about the simple asynchronous consumers, and then I can also try to, now I will take, because I want to show a different type of consumer, which is delegation one. Let's see what's the option for that. Async delegate. Same thing. Here, this hello message is implemented. Okay, and it does the same thing for the same process message. And of course, this print is called in the main thread. This print consumer is called in the main thread of this one. Okay, so this has been overridden and causes the thing. So you can see here, here lies the call to the EMS report to pass on the message consumed from the EMS queue. Also, any response returned from the EMS queue call can be sent back to the requester as a reply queue, and the correlation ID are available as part of the JMS header of this message. Okay, and if you see here, of course, don't be confused with the void return here, because we are talking at the messaging level, not at the function level here at the moment. Okay, but the call to ONT, if it returns anything, okay, that return can be used to send back the reply. Okay, and number of session parameters, as I told you, is part of the constructor shown above, and if number of sessions is specified, that should be treated as one instance of. Here, it should be handled by this way. Okay. Okay. So now they are all running, but here also you will see now the IDs have changed. 1721 was the earlier consumer IDs, now we have 26 to 30, and of course the same connection. Of course, connection would have also changed, and they are all after queues, and there's no message sent to them at the moment. So what I can do is I also can try to send 5 messages in a row of both the types to this type of consumer. There you go. You get the, probably I can see all these 5 now, because I have, 6 now, accumulate output. So I can see the message IDs of all the 5 here, because I have used accumulation in a loop. So I can see all the message IDs of all 5 messages, FF messages that have been sent. And Now they have sent, let's see what have they say. Yeah. 48, 47, okay. 49, 45, 46. And if you see the calling sequence now, process message, the last one, handle message, and the on message. Now, it means that your delegation is also inheriting somewhere from the message listening mechanism. So ultimately, it's the on message method only that gets called implicitly by runtime, which in turn calls the handle message which you had overridden. So that's one discovery which we made when we print the method call stack. So rest is just the same. So, and they are all consumed by different threads. Okay. Processed by different threads and not by the main thread, which is this one. Okay. So, and here also you will see that now they have been equally distributed with the messages. 5 messages, 5 FS messages, then of course you cannot see here the 5 FS messages. And of course you cannot see the thread IDs also because it has got nothing to do with thread basically. It will talk in terms of sessions and consumers and connections only. This tool. Okay? So for few threads we have to print the thread names and all in the log of the .NET application. So these are the 5 messages that have been equally distributed. Now let me send the, here we go. Have I accumulated it? Yes, I have. So I will be able to see the replies. Let me see, not this one, sorry. Yeah, I am able to see it. So, in the output, you will see the reply also. So, let me see the last one. So this one that was received. This is an RR1, request reply. Yeah, as you can see the reply to queue is temporary queue here. So it checks for reply to queue. If it's not null, it will think that of course it is expecting a reply and it's listening on this particular queue. Okay? And I have to reply back on this queue. And then this reply has been sent, which is the same, Because the same method, this process message is called by all the consumers, so you will, just for uniformity, I, use the same method. And then of course since it's the same method, I have to, then use the method calling sequence so that at least one can distinguish how this method or the method chain was, restacked or created starting from there to here. Okay? So this one is just the same as this one. This is the last one. I can see the last one in the output. And these are the header properties, the priority, queue, and persistent and destination and all. Okay. So now we see I had sent before 5 FF messages, and I have sent now 5 RR messages. Let me show how they are distributed over this. You see that they are 2 each now. So the 10 messages have been distributed uniformly over 5 consumers with different session IDs, and they have been concurrently consumed and processed. Okay, so that's the simplest thing. I can also try to show you. Okay, that's very important now. The most important thing that was done in how I created the synchronous consumer. Okay. Of course, being a consumer, it has to ask only for the queue name and the number of sessions. Okay. That's the standard for every consumer. The way we are receiving messages synchronously or asynchronous but later. But the thing is, if you want to create consumers, you have to first think of queue and the number of sessions as per the current design thought process that I had in my mind. Okay. So, the Q&A and the number of sessions are the two ones, and then they are, created. And here I have done some thread programming. So,
can I pick it up for him? Thing is that, yeah, so it's really shortage of time. There are some meetings also going on. So, what we have tried to achieve, can you just summarize that and what is the capability, whatever is left, if you can just summarize that in terms, because I understand that what you understand is yes, it is possible technically to achieve what we have promised or what you have suggested to me then, and we have given some demonstration of that already here in terms of the POC. And now what is left, and finally if you can summarize, then you can go for the next meeting.
Sure. I have, talked to Anshuman and Suhas before you guys came, and I thought I would, overshoot the time by half an hour, but now I'm not able to get even 1 hour, but anyway, I can understand that. So just I will take another 10 minutes, because anyway we started at about 12:10. So this one I had, created share for every session, and which basically, runs in a context loop. So if there are 5 sessions, there will be 5 threads, and each thread will be running its infinite loop. And that will be, and you will see exactly the same behavior as you saw in the asynchronous consumer, with no new consumer IDs or session IDs created. Okay? So that's the only difference between the synchronous and asynchronous consumers. Other than that, it's all the same. But we will still, probably propose that it is basically asynchronous messaging using message listening mechanism, which probably we can take ahead and try to, But anyway, these are part of libraries. A developer can use all these, any one of these 3 if he wants. So let me come to the. So this was basically the consumer part, and then I had also, had planned to, demonstrate how to, how a client, a CMS client or a .NET client can act as a producer by sending the messages to business works and then receiving the optional replies and all. It's just the roles have been changed, the roles have been reversed. So here now the .NET client becomes the consumer, the producer, and the business works becomes the consumer. So I will just walk through those. There are sync consumers and there are async consumers. So let me show the async consumers. So basically there is one with no reply, okay, and then there is the reply one, which is this one. But I am going to merge them into one. It's just the same which I did in the .NET consumer. If you reply to queue exists, then reply to. Otherwise, just do nothing and confirm the message. Okay, that's pretty much it does. And of course, here it's supposed to have number of sessions, and of course a tune which all is listening. And this is a configuration. Okay, this is a configuration you will see somewhere here. Okay, this one. And this is also a configuration. So that's pretty much it. This is the asynchronous consumer. Okay. This activity is just I'll take another 1 minute. I would say
Madan, they already people in the
Okay. Just now. Okay. Let me just. This is our end, desired situation. Okay. So there are a number of clients, EMS producers or requesters, and this is your consumer. And every consumer on .NET has its own session and thread, and there is a call from EMS framework to AMP framework within one thread. And these are all done in parallel. So that's what is the desired situation at the moment, and this is your typical EMS, and the consumers of ISS, they create the sessions, and then they are then they are doing their work. That's the way they are coded to do the work. And we have all types of vendors like Gitco, BusinessWorks, Dovetail, Java, SAP, okay, and Finecto. They all can send, I'm sure, the messages to the users.
What we do, Nandan, is let Vermeer and Janik go through your presentation. Maybe, Suman and Swaraj can do an offline thing because the guy is already queued up and we have to communicate for now. So let's spend the time here, but I think the main message that you wanted to put across is quite clear. That it's technically possible and you are doing some demonstration. We'll go through the additional presentation in offline with Suman and if really we address with you also at the
Yes, sure. And I'll update the PPT because I've missed this slide, okay? And this is very important slide, okay? And then probably we can have a discussion later. Yeah?
But thank you so much, Nandan, and Neetu and Jitendra for coming and showing us and giving some, confidence to the guests. This is something we can do. Let them decide and first let's finish the presentation offline and then we'll come back to you.
Sure. Thanks. Okay. Thanks everyone.
Bye-bye. Thank you.
Thank you.
Thank you. Bye-bye. Bye-bye.
So, let me come back to the synchronous consumer, which is here. So given the number of sessions and the queues, so sessions are created, receivers are created, and for every session, a thread is created, and each thread then runs the infinite while loop. And they all run in parallel, the threads, and that's the main feature, or I would say a drawback, that you need to explicitly write or create threads for synchronous consumers. So let me try to demonstrate it for you. Now I have to kill this one, okay, so that now there's no consumer over this queue, but create so you see that there are now 5 consumers created, but these all 5 are synchronous consumers. Okay? So each synchronous consumer is required to call this message. So now if you see here, this is using this receiver receive call, you get the message, and you pass on this message to receive and process message function. Okay? And this is the function. And it's virtual work, and it needs to be overridden in the deriving class, or in the child class. So that's what has been done. Okay. So this one has been overridden. So this class this one has been, but not this one. This class, derives from this class, which is the same as as class. Okay, which creates a consumer value. So now we need to just override this function. It again calls the same process message, and then after acknowledges if somehow not able to acknowledge it in here. Okay. So now if I extend the same stuff to okay, let me send 5 process messages to this one. $29, $80, $81, $77, $78. Okay. So it's just the same, and if you see this is the receive process message. So here it shows that it was received asynchronously, since the method is received and process message, and which in turn calls the process EMS message, which is the common function which I've been calling in other 2 types of consumers also. Okay. So let me see, now the 5 messages and they are all 0 at the moment. So 1 has been equally distributed. Yep. And now let me send 5 other messages. Yeah, you get the reply immediately almost. Just the same reply, and this shows that this is the sync mechanism, because this function is only implemented in sync consumer. Yeah. So this pretty much finishes our consumers in .NET and producers in BusinessWorks. So there might be another requirement where we reverse the roles, where BusinessWorks act as a asynchronous consumer and the .NET application acts as the producer. So let's talk about that a bit also. So these are the consumers. One is with no replier, and another is one with the reply. Yeah. So I have merged these 2 into one. It checks with whether the reply to Q exists. If it doesn't, then it does nothing and just confirm the message. Or if it is there, reply to Q, then it simply sends back the reply. And this is the reply that you see, which comes from the process message. And this one is simply, sending the BusinessWorks runtime material. Okay. Process name, which is the process name is your BusinessWorks process name, which will be this one. Or whichever process is there that's executing this function. And the process ID is there, is the job ID basically. So let me at least demo this first. And now if there's anything running, I can kill this. And see there are no consumers. But now the consumers will change because this will be the business works consumer and will be looking on this queue. And if you see the queue, is this one and not this one. This is the queue that has to be tapped. So there is no consumer at the moment. But when I start it, you will see some consumer and with these many consumers, So number of sessions is 5. So start it. Start it. See, there are now 5 consumers of this queue. Okay? And now it will be triggered if I send some message from the .NET producer, which is this one. Yeah. So basically, it checks whether it's SFS or RRR on the command line, and also optionally for correlation ID. Because there is another third type of consumer which you can write in BusinessWorks, which is very selective and which will consume only messages which match the correlation ID which it has with itself. Okay. So this is your just like in the .NET consumer, I would again, just for for clarity, I have renamed the thread according to the same naming convention: the machine name, process name, and process ID. So this is your message that will be sent, hello there, and machine name, sending process name, process ID, process name, process ID, and method name, which always will be, name and the current thread name, which again will be the main thread name, I think, and the client ID, and also checks if there is a correlation ID, and if it is, then the BusinessWorks, a special type of BusinessWorks consumer, looks for it. But basically, you have to run that BusinessWorks consumer, that type of BusinessWorks consumer. So if it is SF, then send only the send message. If it is RR, then send request and receive reply. So it sends the message. This one particular function sends the message and waits in a reply queue for a message which is this one, for a reply. Okay. So here it is. Let me try to find out where it is. It's here. Yep. Let me try run it. Let's send the SF message first. And I think it's already running, and if you see it's there are 5 consumers which are BusinessWorks consumers, and you can see the BusinessWorks consumers because this is connection ID. This is connection ID 33, and they are all using 33 connection ID. Okay. and this is of course the designer that's running the consumer. Yes, if you see the conflict, it will be also looking for the sending. It has to send the message on it, basically, which is the same as your business process consumer system on. Okay. So let me try this. It's all sent, and you should have received something here. Yep, you got it. So this is it. So there's no reply because it's an FFF thing. It just confirms the message. It goes. Yeah. So what's the hello there, and the machine name, and the process name, process ID, method, and the thread name, which is always will be the main thread, and the client ID. So that's what it is, and it's just about to fly and of course forget. That's what it does. Now, what I do is I send, and if I see the consumers details now. What? No, sorry, it has to be needed new, yeah, this one. So one message has been sent and one has been, received and acknowledged by this one, this session 110, okay? Yeah, so, let me see matter one more. No. Yeah. So it gets some response back, which is your business work details, machine name, BW project, job ID, thread name, Docker 6, and then the process, sending process, the replying process, which is same as this one. Okay? See, or you see here that reply key is not known, it has to send back the reply. This is what it says. Just the same. 201 and 201, short for 6, short for 6. Yep. So now what we see here, what I can do is now, I can run this in a while loop maybe. Yeah. Infinite while loop I'm going to run. That means there will be infinite number of messages sent to this consumer, and we'll see how they are going. Here they are all coming. So what I do is I try to fill it, and now it will be stopped. So I don't know how many were sent. All reply ones. So if you see here, so 34 messages were sent in this loop. Okay. Or not in the. I think there were about 32 messages sent in the loop. First two were all this and this was which was sent in one iteration, but from here to here, that was one big while loop. Okay, and 32 messages were sent, and see how we have distributed. Yeah. So that's a simplest type of consumer in business works. There are other types of consumers also, and of course, and this is the one that SOAP one, and you need to be very, very particular when you are writing a SOAP-based consumer, because it will ask for abstract visual if you're writing business works. And if you have invoked it, suppose you have written a .NET-based SOAP service provider like this in .NET, in order to invoke from BusinessWorks, you will need a concrete business. So this will be used to invoke any .NET-based SOAP service provider. Okay, and for this, it will need the concrete visual. So without concrete visual, you cannot write a BusinessWorks-based SOAP service consumer. Okay, so that's very, very important. So now here I have written both consumers and providers. They are in the same BusinessWorks project, so there should not be any problem running them. This is the one, and this is the one. Here. If I send message from here, so 5 messages have been sent in a loop, because this is the same as this is 5. There's the zero message, and 5 iterations of 5 invocations of this have been done. They all wanted the reply. It goes this way. Yeah. Okay. So this is very strictly standards-based service design and development in Cisco BusinessWorks. There are other standards also like this, but this is beyond scope of the current presentation. Okay. So now we come to these all are asynchronous consumers. These all, including the SOAP one. Let me come to the synchronous ones. Okay. So this is what we were trying to do in IFS when you were receiving the message and then confirming it. And in a loop, you are doing it this way. If this is an infinite loop, condition is always true, and you are consuming a message, coming back to that after consuming, doing whatever is required to be done, and you're doing it, right? So let me, first of all, run this one first, which will, show you. Let me, we have no counter now at the moment. Yeah, so there is no consumer. Okay, so we can stop here. On startup means when we use startup, so I've used this particular startup activity just for so that as soon as your message starts, you able to invoke this process and get straight to consume the message synchronously. So So now I have to, since it's waiting for the message, and see how many are there. So there's only one session that's created, because it makes sense, because here it's a synchronous one, and it's not like called in a loop, or it's not in a multi-threaded. So it's just this one simple thread, and then which is this one. So this is a thread name that's set here, and so now I have to invoke one aura or whatever. If you invoke aura, you will get some message. There you go. So it just receive the response. And if you see what? Yeah. So that consumer is gone once it's consumed a message. Okay? There you go. So once it consumes a message, it does what it's got to do and confirm it, and that consumer is destroyed of code, or it goes out of scope. This particular activity, creates consumer and corresponding session, which you could see here while it was listening. But since now it has received a message, it has replied, and now it's gone. And you cannot see any consumer on the queue. That's what it is. Now what you do is, or what you try to do is, you try to put them into a loop. The same thing. I can also try to put a loop here, just the way it's done there. But it's already done in this one. So it's a endless loop, and it is of course accumulated activity, output activity of this one. Yeah, so it will show in the loops the output of all the iterations. Now let me try to run this. Now here it's like how it's endless loop, yeah. Yeah. So that's what we generally do. We put this receive or generate the message in an endless loop, and then you receive it as and when we receive the message as and when the message comes. So, but that is again not concurrent, that's sequential. Okay, but anyway, let me try to demonstrate it. So it will be the first iteration, it's end of the first iteration and it's waiting for it. So there will be only one consumer at the moment. Yeah? Consumer ID 116, connection is 82. That's it. So, yeah. Now I send one error message and it comes here, but it does receive the message. So it has entered the second iteration, it has gone there, confirmed the message and returned here. Okay. And if you see, the value of I would be 2 and not 1. And of course you will see the, sorry, yes, here. And output from the first iteration. Okay. So now if you see another consumer, or yeah, it would not be same. It would not be 116. it should be something different. So every loop, every iteration, you create a new consumer. Get the message, receive the message, do whatever is required to be done, reply optionally if you have to, and then confirm it, and then get back here and create another consumer and start testing. So that was an endless loop, and that's how you do it. But you don't get the option of, specifying the concurrency parameter here. You can't, Maybe you have to do something else. Why not, put this whole loop, like I did in .NET, in a function, process function of this work, call it in an endless loop, okay? And on top of it, you have to thread it. The number of threads specifying the number of sessions that can be created. So this is the one. So here, number of threads of consumer is the 5 that will be created. And how to create thread? This is again a loop, right? And within the loop there is again a loop. So what you do is just simply spawn it, and that means they will run in their own threads or process or their jobs. Okay? So let me try to start this. Sorry, this one is one, right? Yeah. Here you go. So the main thread is gone, but the 5 threads are still running. And now you would see 5 consumers. 1, 2, 1, 2. Yeah. But once you consume the message, then there will be, for a particular thread, there will be a new consumer created in the next iteration of that loop that's running in the thread. Okay? So let me try to send one. Yeah, you get it. So 2402 is the job ID which is used to send the 2402. This is the one. So if you see here, the value of I would be 2 and not 1 because it already had 1 iteration. Okay, yeah. I'm not yet accumulating it. I should have, but anyway. I should be enough to tell that so this one. And if you see here, you will see the value of I as 1 only. Because it is in its first iteration. All of them, except this one. This one, 24002. Here also you see I is equal to 1. Here 2. Equal to 1. Okay? But here it should be 2. Yeah. So yeah. So only this particular job, a thread I would say now here, that receives this message, and rest all are still listening, because anyway there's only one message that has been sent. So now let me send one more. So now this one, 04 has received it. This one. So here the value of I should now be 2. Yeah? Let me send one more, and then all other, it's only 2 and 4 and 2, they have received the 2 messages and process them and send their replies back. Let me send one more. So we'll see. Again, it's 2. So now 3 messages are sent and they are received by these 3 threads. So here, but now you would not, 3 threads have been, or 3 consumer IDs have been, used up, and these and 3 out of these 5 consumer IDs should be replaced by new consumer ID, and 2 of these should still be seen here. So 1 to 1 and 1 to 2, 5. So we have 5. How many we have? 1 to 1, 1 to 5. Yeah. So 1 to 1 and 1 to 5 still remain, and rest 1 to 2, 1 to 3, 1 to 4 they have been used up, have gone out of scope after doing the work, and they've been replaced by 3 more consumer IDs. So here you see that it goes in a loop and comes back and creates a new consumer ID and the session and that. So there is a continuous creation of consumption of message, processing of message, and back to the initial activity of creating the consumer, consuming the message, processing the message, confirming the message. So that's how this particular multi-threading effect is achieved. And where the main thread goes. And then, of course, it ideally should wait for child threads. That's better thread design, I would say, using some thread communication. But I probably would not comment on this particular thread design where the main thread goes off and the newly created threads they are still running. Anyway, the process is running. So don't worry about those threads, the child threads. Although there's no concept of child thread, but yeah, these threads die away if your pen goes. So so that's the multi-threaded synchronous consumer in BusinessWorks. Another consumer is this one. That's a very special type of consumer, which is very selective. So it will look for a particular value in a particular field of the JMS header, and that particular JMS field in the header, for example, can be JMS correlation ID. Okay? So only if the correlation ID in the JMS header matches with this value would I be able to okay. So now it is waiting for it, and you will see here that there is one consumer and it is waiting for a message. But if you send a message with correlation ID is not equal to abc.def, okay, then it would not. It will simply acknowledge it, and it would not send it forward. It would not trigger the remaining part of the processing. So now if I send, suppose so this was set to 0. Sliding is unique in its behavior. So I am not sending any consumer ID, or I am sending consumer ID or something like this. Now this chap has sent RR. It is waiting for the request. Sorry, for the reply. But now, only this consumer, which is this one, is listening on this queue. It might have seen the message, but it's chosen not to, proceed ahead with this message because the correlation ID of this message doesn't match. Okay, so let me now, but since it doesn't match, it will not never send any reply because it has to come here and it has to send the reply back. So this consumer would wait endlessly. So what you can do is you can kill this consumer at the moment. Let me try to put this in explanation, okay, and this one. So now at the moment there would not be any consumer, it was gone. Let's start again. So now, that's again some internal mechanism which is unpredictable here, even for me, because I see two consumers being created because one message has already been sent, even though it ignored that message, I would say. When I say ignore that message, it did acknowledge it somewhere, but did not let it go through this part. So here you see, I would say when I say acknowledgement, it did know that this particular message has been received. So what I do now is, this is tricky. I send so you can see that there was no reply received because the correlation ID did not match abc.def. But now it should receive some reply. It does. But here it keeps on listening, and if you see, so this one particular has been the second message. Acknowledge it as well. So maybe I can try to see what's the value of I here? Yeah, 2. So there's, send this. But if you do not have something like, it would always wait endlessly because it's not abc.def. So it will, I don't know what. So this one was sent, but it was not acknowledged, and I don't know what has happened to that. So there's one pending message which was the one which did not get acknowledged. So if I send one more to this consumer and send one, yes, now that's pending message increased to 2. And let's see. I think so that it should now be 3. Yes, 3. Yeah. But yeah, the receivers has also increased. So I think you should see the increase in receivers. Yeah. So there is but you see the consumers 139, 140. Okay. 139, 140. So they remain the same. They are not destroyed and recreated in this case, right? But it's slightly unpredictable. I would say, we have to look closely into this activity, the behavior of this activity, but it's mostly meant for, correlating the messages, like I demonstrated here, and in the same session, where, you want to do further correlation and then do the request response mechanism. So that's and this one whole is, I think, running in a bigger loop, in another loop here, and that's again spawned out as you see. Yeah. So these wait for, and this is get. So these are two ways of synchronously saving messages, and so that's the way you create these synchronous consumers. So that was the producer in .NET and the consumer in BusinessWorks, and they are, and you can see that producer in .NET is not bothered about the number of sessions because it does not got to do any work. It would just simply send the request if it has to, and then wait infinitely if it has to. Wait for them to reply. Nothing else it does. But since now this has to do the work of a consumer that process the message and send optionally back the reply, it has to bother with the queue as well as the number of sessions, which is 5 here. Okay. And then of course these producers are implemented in this DLL. Yeah. And this is our end desirable situation where you have n number of EMS clients, service consumers or message producers sending messages to the .NET service provider or .NET EMS consumer, and so I hope you can. This is the sessions and the corresponding threads, sessions with the EMS and corresponding threads in the .NET, and then every thread is having the call from EMS to AMP server through this on message. Yeah. And your Doctail, your Java, your Space and Echo, Kubernetes, all talking to .NET through EMS. Thoughts and instances? Well, it's quite self-explanatory. So there's no set program required for asynchronous consumers, and it achieves the vertical scaling in a single process. Yeah, small enterprises don't need to run separate processes instead of using an OS level because generally in small enterprises you don't find a very big size messages generally, and the rate of message flow is also reasonable in a sense that it's not overwhelming. So you can you need not go for running separate consumers in separate processes. You can run them in the same process and scale them up through the number of sessions parameter. So if there are a small number of big size messages, that means number of sessions is slightly insignificant here, but the memory is. So here you have to think about tuning the memory rather than increasing the number of sessions. But if it's high number of small cell messages, then it's just opposite where the number of sessions is also important, and also the number of memory is also important, but not as much as the number of sessions, because the higher the number of sessions, the memory will also need to be higher, because the context switches also happen internally at the OS level and at the process level, basically. So this has to be also be looked into. And if both are high, the size of messages is high, is big, is large, and the message flow rate is also high, then you can go for either horizontal scaling or vertical scaling. But in the case of vertical scaling, you have to have very high memory allocation, of course, significant number of threads. These two are the most important tuning parameters, or performance tuning parameters, and we will have a better representation in the next slide, which is this. So here you can see that the message rate remains same as at the rate of 10, but the message size varies, the complexity varies, and accordingly you vary the number of sessions and the memory. And and then you have the complexity definition, what is simple, what is average, what is complex, what is very complex, and then you have the definition of particular and horizontal scaling. So from low to medium and from average to complex, for this message phase, the number of sessions should be less than equal to 5, but you need to scale up your memory. Okay, and for very complex and high message sizes, from medium to high, or even medium, probably you need to scale up both. QA, since this is a recording only, so probably we'll have this QA later sometime when you guys can deploy it, ING, goes through this PPT, and maybe this recording also, and come back with the questions. There are additional questions and doubts which I have found and which I have reached in the POC. So if you see that there is some coupling between the DLL and the configuration. So this is for taking the control away from the developer for creating the connection. So developer would only be concerned about changing the connection parameters in the connection in the configuration. The rest is done at the startup by the DLL code. Okay. So, but still, if you somehow can lose the coupling, it will be great. But these four conditions should be met. Okay. So in a single process space, there should be only a single connection object, unless there is bad need of creating some admin object or something, or some other connection object. And it should be created at startup with no explicit constructor call. That's important. Okay. And of course, as I said earlier, developers should need to provide the connection parameters only to the configuration. So another point is that in synchronous consumption, I had to create explicit threads, unlike in asynchronous consumption where the threads are called or used implicitly by the virtue of you implementing or overriding the on message function. Okay, so how to if I in a loop if I'm able to create 5 sections, that means 5 threads are also created. How to access those session threads? Okay, so that's a big question I have in my mind. Generally, we access threads by their thread instance of names, but you would only have a session ID or the consumer ID. Is there a way for getting the thread object out of session ID? That's the question. I do not see any. No. The third inference is that it's not returned by message producer API. The message ID is not returned. While in business bus, you do get the message ID. So if it's not returned, then you have to use the coordination ID for message tracking purposes. Okay? Or probably you'll have to find another mechanism of tracking the messages through some other field. And that's the fourth one. So now if I have a producer sending about 10 messages and there is no consumer at the other end, those 10 messages are lying in the queue and I'm waiting for some consumer to come up and consume them. Now a consumer comes up which has about 5 sessions, or say 4 sessions or 5 sessions. Would it behave the same it behaved when it was up with producer sending the messages? I've seen some deviations from this uniform distribution when consumers comes up later. And this is basically applicable only for FX. In case of RR, consumers has to be there before an RR message is sent. Okay? So that's pretty much it. Any questions, any doubts, just get back to me. You have my email ID and my telephone number. And we'll see then what can be done about these questions and answers and the problems, and we'll sit together and sort it out. Thanks very much. Bye.